Hi guys, welcome to Dr. Radiation channel. In this video, we are going to talk about the differences between X-rays and gamma rays. Let's first start with the nature of these rays. They are actually both electromagnetic radiation. And if you don't know what is electromagnetic radiation or electromagnetic wave, I should tell you that they are a type of energy that travels through space at the speed of light. And they are made of two components of an electric field and a magnetic field that oscillate at right angles to each other and to the direction that the wave is moving. And if you look at the range of wavelengths of this electromagnetic radiation that we also call the spectrum, it starts from the radio wavelength or radio frequency when the wavelength is around 1 kilometer to shorter wavelengths like microwave, which is just 1 centimeter. And then we have infrared and visible light and ultraviolet. And you can see that the approximate scale of the wavelength, structures in the nature that is comparable to these wavelengths, and based on that, these electromagnetic waves can penetrate into those structures is like this. For example, for ultraviolet, you can see is comparable to the size of molecules. And X-rays and gamma rays have the shortest wavelength in this spectrum. And of course, they have the highest energy. So when we have a shorter wavelength, we have a higher energy. And as you see, X-rays and gamma rays with shortest wavelength, they have the highest energy. But what I need to tell you is that this is not something that you can generalize. You may see such a range of wavelengths and frequencies for electromagnetic waves, but it's not always like X-rays having a lower energy and higher or longer wavelength compared to gamma rays. We have some examples that we can produce X-rays with higher energies than gamma rays. Now, after knowing that they are both the same in nature, let's talk about how they are produced to know about their differences. X-rays actually can be produced when we have an atom, and you know about, or you already know about the atomic structure from the high school physics or chemistry, and you know that we have nucleus with neutrons and protons at the center, and we have orbital electrons or atomic shells containing electrons around the nucleus. If one of these atomic electrons are given enough energy to be detached from the atom, and actually the atom will be ionized. So the empty space when the electron was placed can be filled with another electron from an upper shell. With this, we will have a difference between energy levels of these two orbits or shells that will be then emitted as an X-ray. So the important thing to note is that X-ray is generated from the atomic shell. And on the other hand, for the gamma rays, we know that they are emitted from the nucleus of the atom, not from the atomic shell. And there are actually internal energy levels inside the nucleus that the transition between these energy levels will give us the gamma rays. So for X-rays, the transition was between the atomic shells, but for the gamma rays, the transition that result in emission of the gamma ray is from the nucleus. Now let's talk about the applications of X-rays and gamma rays to know more about their differences. X-rays actually are used in medical imaging, in dentistry, and also for actually every part of the human body, mostly to see the bone fractures and anatomical disorders. Other than medical imaging, they are also used in non-destructive testing when we can find and detect the fractions inside tubes and other structures by images that are produced by X-rays. The other important application that you can see in everyday life is security scanning for suitcases, for example, in the airports, or for cargo imaging at ports when you can see inside big cargos for the security reasons. And the important thing is that all these X-ray sources that are used for this kind of application are artificial sources, are human-made sources. On the other hand, for the gamma rays, the main application, we can start with the nuclear medicine when we have, for example, PET images that are produced using the radiopharmaceutical that are actually emitting gamma rays, and these radiopharmaceuticals are injected into the patient body. So beside the CT scan image that are showing the internal structure, or basically the anatomy of the patient, we can have information about how the organs of the body are functioning. So CT give us anatomical information, while PET give us about the functioning and how the organs are operating. And this is using gamma emitter radiopharmaceuticals. The other important application is, of course, for the treatment of cancer and what we call it radiotherapy. There are actually gamma sources, mostly cobalt 60 sources and iridium 192 sources that are used to target tumors. And this is, for example, showing a brain tumor that is targeted using several beams of gamma rays. The other important application is for irradiation of foods for the purpose of sterilization. Can be used for fresh fruits, fresh meat, for dried fruits, and so on. And there are huge facilities that actually keeping high activity sources, gamma sources, to be able to irradiate the foods for the purpose of sterilization. And the important thing to note here is that these sources can be natural or can be artificial. X-rays, these are the main differences between X-rays and gamma rays. X-rays are emitted during electronic transitions in the atomic electron shells, but gamma rays are emitted from the nucleus of an atom during radioactive decay or nuclear reactions. The other important difference between X-rays and gamma rays is that X-rays are typically generated by artificial sources such as X-ray tubes or linear accelerators, while gamma rays come from radionuclides, which can be natural, like uranium and radium, or artificial, like cobalt 60 and iridium 192. I hope this video was useful. Thank you for watching.